This is problem number 13 from section 3.3. The question is to draw the phase plane for a particular second-order differential equation that was worked on in a previous section. Here's a second-order differential equation. We could associate it with a damped harmonic oscillator if we want to. Here we are turning it into a system of first-order differential equations, and here we're writing it in matrix form. The matrix has two eigenvalues, lambda 1 and lambda 2. They're both negative eigenvalues. Two distinct negative eigenvalues means that the equilibrium point here will be a sink, and we compute previously the corresponding eigenvectors, v1 for lambda 1 and v2 for lambda 2. In the phase plane, we draw the v1 direction in the direction of 1 minus 2 over 1, over 1 down 2, and similarly v2 over 1 down 5. So here's v2. It's a little steeper. Here's v2, and here's v1. Not quite as steep, but still they're very similar. When you look at the general solution, the rule is that you will approach the origin in what we would call the faster direction, e to the minus 5t. That's the v2 direction. So things approach the origin parallel to this direction. We approach it parallel, but as we get closer, this term is insignificant, and this is the direction, the v1 direction. So as we approach the origin, we come in. We started off in the v2 direction, but we come in the v1 direction. Here we're in the v2, but now we start to turn and we end up in the v1 direction. From the other side, again, we're coming in parallel to v2, and then we turn towards the origin and we approach it in the direction of v1. We turn and approach it in the direction of v1. In between in this little v here, in between these two, it's a little tricky. We're just going to draw everything going straight in towards the origin. It's not enough room to differentiate, but we will always be approaching in on the side closer to v1. Okay, that's what the phase diagram looks like. Thank you.